The purpose of this video is to go over how to do this real-world polynomial problem. So we have a tank for an automatic timed water fountain. It begins with 30 gallons of water. Some of this water evaporates during the tank before the tank is filled up. After the reservoir is filled, the water fountain then turns on. The amount of water Y in gallons in the tank can be modeled by the equation Y equals negative 2x cubed plus 14x squared minus 4x plus 28, where x is the amount of time in minutes. So what you should be thinking about is, a graph of this, right? We can have a graph of this. And Y represents how much water is in the tank, right? The water in the tank. And the X value is time. And this is really just to give you a picture of what we're doing. The actual problem is all algebra. So the amount of water Y in gallons can be modeled by this equation, and X is time. So we're supposed to find the zeros of Y. The first thing I notice is this entire thing, every term is divisible by 2. Also, I don't like this negative sign that's in the front. So I'm going to get rid of that as well. So I'm going to factor it out. So I'm going to factor negative 2 out of every term. So this will leave me with x cubed. And 14 divided by negative 2 is negative 7x squared. Negative 4 divided by negative 2 is positive 2x. And 28 divided by negative 2 is negative 14. So now I look for another factoring opportunity, and this thing can be factored by grouping. So I'm going to group and factor out an x squared. What I'm left with when I do that is I get x minus 7. And I'm going to factor out 2. So again, it's a plus 2 out of 2x minus 14. And I'll get x minus 7. So this whole thing, when I factor this right here, I'm factoring out the x minus 7 from both of those groups. So I'm going to be factored out as x minus 7 times, and I'll put this in red so you can see x squared plus 2. Now we can't forget about the negative 2 here. Okay, so we actually factored out the function. So what we should know right away is that we have a 0 at when we set x minus 7 equal to 0, and we solve it, we get x equals 7. So that's one of the zeros. So x equals 7 is one of the zeros. It says find the zeros. We already found one. And then the other 0, we have to take the other factor, and we have to set that equal to 0 and solve. So we're going to subtract 2 from both sides. We get x squared equals negative 2. And then we're going to have to take the square root of both sides. So we get plus or minus the square root of negative 2 is equal to x. Well, that's x equals, and it's plus or minus I times the square root of 2. So that's our other set of zeros. We have x equals I times this plus or minus, let's redo this. We have plus or minus I times the square root of 2. Okay. Oops. So here is our zeros. Now it says determine if the zeros of Y make sense for the context. Justify your answer. Well, I think that the one that makes sense is t, or time, is equal to 7 minutes, because this is a real 0, right? The other one's imaginary. It doesn't even show up on the chart. So 1, 2, 3, 4, 5, 6, 7. We have a 0 here. The other two don't show up. Remember, if we go back to our original equation, we have a y-intercept at 28. So we're way up here at 28. Water in the tank. Okay, so there's 28 gallons in the tank. We had a negative cubic. So the end behavior is going to look something like this. And somehow we're going to probably come through this point and come around here. Okay, and they're in no way, shape, or form do the imaginary roots come into play. So the imaginary roots do not make sense in the context of this problem. They're not real. And that is all I have to say about this problem.